I see live. Hi, my name is John McMaster here in my Silicon Valley garage.
Hey, and I'm Yusuf. We're back after quite a hiatus, and we're back with another guest host. Ryan, why don't you go ahead and introduce yourself?
Hi, I'm Ryan Quarantiano. I'm here in my Los Angeles laboratory.
So today, why don't you set up? I can just talk to the audience for a bit. Okay, so today we're going to be looking at pulling out the bond wires from chips. There are a whole bunch of different techniques that John and Ryan are going to go through. Hopefully they'll be useful to a lot. This video is going to be kind of a longer form video and somewhat of a tutorial. So, a slight departure from what we have done previously, but hopefully it'll be interesting to everyone.
Sure. Okay, so let's talk a little bit first about what are bond wires and why do we want to remove them? Yusuf, do you know, for example, what bond wires are on a chip?
Yeah, so you have the silicon, and how do you connect the silicon to the, outer world, right? With these little wires that are all pretty microscopic that connect to the little, pins on a chip or the, pads on the chip.
Sure. Anything you want to add there, Ryan?
Yeah, I think you said it perfectly. These are wires that basically allow you to attach the pins of the actual packaging of the IC.
Sure. And why do we want to remove them? Like, what's the issue there?
Personally, well, I want to remove them because sometimes they get in the way of the photo. I mean, after decapping, sometimes these wires can be all over the chip itself. It can be actually covering the die. So when you go take images of it, you just see wires everywhere. Another reason why you want to remove them, even if they're not covering the die itself, is just for aesthetics. You don't want to see a bunch of wires poking out while you're taking a photo.
Sure. Okay. So with that in mind, then the issue is, they're very small, and there's a lot of things, that can go wrong depending on the technique you try. You might scratch the die if you're using tweezers or something of that sort. So in this, then what we're going to talk about is different ways that myself and others have come up to remove those bond wires in a way that's both safe to the die, that's time effective, and also safe for the user, as some of the things that we'll discuss also are rather hazardous, depending on your risk tolerance. Maybe we could start by talking about plucking, which I would say is the most traditional way to remove these wires. Ryan, I think you might have a demo prepared for this.
Yeah, so let me share my screen.
Perfect. And I guess we'll get a light on there. Okay, we can see your microscope there. And while you do that, I'm just going to make sure that our live stream is set up correctly. All right there. So I see a chip starting to come into focus there. Okay, and we've got a few wires on it. Now, in this case, it looks like you have gold bond wires. Is that correct?
Yes, sir.
Gotcha. Now, for some of the other techniques that we're going to cover, the actual wire material can play a big role, but for plucking, basically anything will do.
Yeah. So generally, so I don't, with chips this tiny, I don't usually recommend using tweezers, just because like the risk of cracking the chip becomes a lot higher because the bond wires are a lot smaller. The bond pads in general are just a lot smaller. So I will go over other techniques other than using tweezers, but I'll show you how to use basically I use two at the same time. So one I'll use to hold down the actual chip so it doesn't move while me trying to pluck it, and the other one I'll use a finer tip and see how fine this needle tip is. So usually I use this one to pluck, and this one can be a little bit thicker. And this one is an actual plastic tweezer, so it doesn't put too much pressure when trying to clamp down on the chip itself. I've had issues where I put way too much pressure and then I'll crack the chip. So this process can be kind of scary sometimes because you either put too much pressure on the chip, you crack it, or with this tweezer, you poke too hard and you crack it. So hoping I don't crack it.
Gotcha. Okay, sounds good. Now, it's also worth mentioning there are carbon fiber tweezers, which are a bit more pricey, but if you're looking for something on the premium end, I would say they're even slightly better than the plastic tweezers. Okay, I have updated the other video to hopefully also be a little more clear where the new URL is. Now, do you usually work under the microscope camera, or are you looking through the microscope itself right now?
I usually work with the, I have these glasses that zoom on that I put on.
Oh, nice.
This is finicky work.
And that's part of the reason why we're going to show some of the other techniques, is because, you know, this is very labor intensive, especially if you have a lot of wires on there. You know, sometimes those wires get kind of matted down and stuck. And so this could be kind of a long, torturous process, especially for a very large chip.
And do they usually come out clean, or is it tough to pull them out?
So you can see that I already got 2 of them off. There's 1 left. They come out fairly easily, as you can see. So those 2 that I had on before are now off the chip. Zoom in a little more. Oh wait, no, there's just 1 left. 2 left. Sorry. So yeah, there was 1. You can see my mouse, right?
No. Oh, there it is.
A little bit, yeah. When you move.
Yeah. So there was 1 right here. So now we can see there's 1 here and 1 here left. So I plucked the other one off. As you can see, it took a little bit of just like scratching around and finally just yank it out. Yeah, I can keep going if you want, but that's just an example of how you pluck out one.
Sure, yeah, I think that's good. So tell you what, give me just a second and I'm going to set up my microscope and I'm going to show an alternate but kind of similar technique. So give me just a second.
So Ryan, usually the bond isn't that strong that it like pulls out
No,
pad
no,
or substrate?
you won't pull out the pad.
Okay.
I would actually say it varies a bit.
Really? You've had that experience where you pulled out the pad?
Yeah, I would say that depending on how cleanly you've decapped it, if you have the pad fully intact, actually a bond wire can be quite strong. But if the pad is a bit more corroded, it may be weakened and actually lift up the wire at the ball or whatnot. So you can sometimes you'll see it either snapping off at the ball or the wedge where it gets onto the die. Sometimes you'll see the pad itself, the metal rip up. But if it's really strong, you'll even see it rip up bits of the silicon below. And I could probably find some examples of that. So it really depends on how you decap the chip. What you're using sulfuric acid to decap, for example, right?
Yes, I use sulfuric acid to decap my chips.
Right, and sulfuric acid is corrosive to metals. So if I had to guess, because of the way that you're decapping them, it is actually damaging the pads as you're decapping them. If you were to use nitric, but not necessarily to a point where it's an issue for most things. But if you were to use nitric acid with high concentrations, the pads might be a bit stronger and you might see that more.
Yeah, I noticed that with when people are decapping with nitric acid, that most of the time after the decap is done, the wires are like perfectly still in there. Most of the time with my decaps, I maybe at most have half. I've seen half of them left, and that's like, and that was a lot for me to have left.
Gotcha. Okay, so what I'm going to do then is I'm going to switch over to my screen.
Okay.
And get a die over here. Let me just get this on screen. I'm going to share over here. And hopefully in a second, you now can see the tube light GUI. Is that correct?
That is a lot of wires.
Well, that's fine though, because we're going to use a different technique here, which goes a bit faster. So first of all, just for reference, these are carbon fiber. Maybe can't see them quite. I'm going to slow down here. These are carbon fiber tweezers that I use. I'm a little bit disappointed they're off the market now, but these were actually very low cost, intended for, let me leave that for a second there. These were very low cost that were intended for plucking eyebrows. So instead of paying, $15 each or $30, they can get quite expensive for these carbon fiber tweezers. I was getting these at least at one point for like $3 or something like that, and I just stockpiled a bunch of them because I was afraid they'd go off the market, and lo and behold, they did. So I have a strategic tweezer reserve here for at least for now, and I really enjoy these. But anyways, enough about evangelizing my tweezers. What I'm going to do is I have these open foam cell swabs, which are typically used for things like cleaning fiber optics. So let me see if I could put one under here and get that in view, so you at least get a rough idea of what these look like. Oops.
You need to focus a little bit more.
Yeah, I'm just trying to. So I guess I could also switch to the other camera, but hopefully this gives you at least a basic idea of what these look like. And these are intended for cleaning optics, in particular fiber optic ports, I think something like that.
I can show on my camera as well because I have it too.
Oh, just those? Yeah, okay, perfect. So if, I don't know if your view is very big, but hopefully some people can see those there.
Yeah, you can see how soft these are. They're very, very soft.
And that's one of the key things here too, is these are very soft. So I can actually apply pressure to the chip a lot more safely than the tweezers. The other thing that I do, which I don't know if this is actually strictly necessary, but I like to also put in a little bit of IPA in here, that is some alcohol, which I find also provides some lubrication and keeps things a little bit cleaner. So
either use IPA or acetone. Are you like switch between the two?
Acetone is a little more aggressive for this type of operation. I tend to use, let me see if I can straighten this camera as well.
So
unfortunately,
what's the bright spot?
Yeah, quite a bit of glare there. Let me see if I can do the auto exposure, maybe either down or on that area. Maybe that's a little bit better. Okay, and then what I'm going to do is hopefully this will stay in view. So with one of these, I'm going to hold down the die, and mind you, that's very soft now. And with the other, I'm just going to start twirling it around so it starts catching these wires. And I can either move them around, or I can just pull hard, depending on how gentle I want to be. And you'll actually see that the wires, especially depending on how aggressive I want to be, are just going to start falling off. And as I'm pushing the metal away from the die, sometimes they get caught like that. I saw as I turned it around. I'm just going to shake that off. We're not scratching the die because we're not pulling any of the gold towards the die, and the gold's pretty soft. The tweezers, the applicators are also pretty soft. They're nice and springy. And you can see that I'm actually stripping off the wires pretty quickly here compared to what it was with the tweezers. And I'm not even being super aggressive. I could even be more aggressive and get these off pretty quickly, move it around a bit. And you see I've almost cleaned off this entire side, which I don't know how many wires that was. And in fact, if you do this carefully enough, which I'm not being very careful right now, you can even do this to the point where you are left with wire studs, and you can rebond even to this. So that's the reason why I switched from using the tweezer method, which I used before, to now using this sort of foam applicator model. It's also worth mentioning that acetone may dissolve some of these applicators, and I think that's another reason why I've kind of shied away from that a bit. But yeah, you can see now that these wires were removed, pretty cleanly. If we put them under a microscope, hopefully we could see maybe a little more detail of what this chip looks like. But you can see no cracks or at least obvious scratches. Does that make sense so far?
Mm-hmm. Do you ever find that any of the wires get caught in your swab as you're moving it around and it comes back and scratches it?
Well, yeah, a couple things. So if you saw, that was one of the reasons why I was kind of rotating it in a circular pattern, was so that if I did see one of them got caught, which one of them did, I brought it to the side and I kind of shook it out. But because I'm also applying very light pressure, and I'm relying more that the wires are getting caught in the applicator more than I am about the pressure that I'm applying. Even if one of them did get caught, it's not a big deal because I'm actually not applying a lot of pressure to the die. Does that make sense?
Yep, sounds good.
And on the same note, it's worth mentioning the wires that I was doing there, they have quite a bit of force. I actually had to pull very hard to even get some of them off. The two options are basically either you can move the wires side to side to fatigue them, or you can just yank them. And if you just yank them, you might rip a chunk out of the die. Depending on what you're doing, that may or may not be an issue. Okay, unless there are more questions, I think that's probably good for that. Let me see if there's any questions. None so far. Any more questions from either of you?
Nope.
Okay. So the next thing I'm going to do then is we can take this one or another one. I have quite a tray of them here that I prepared, all these poor little flash chips. By the way, you can tell, yeah, these are all T-stops. Fun trivia, I think these were from Lytro cameras. I accidentally bought Lytro's, like their RMA inventory once at industrial auction. And I tried to give them away to people for a long time, and eventually I just kind of scrapped them. And I think these are like old Lytro flash or something like that. But anyways, random trivia. So I'm going to go over to, I'm going to disconnect this camera so you may lose the video feed here. I'm going to hit stop share. And I'm going to walk over to a different station where I'm going to show you how to use a heat gun, basically molten solder. And Yusuf, you and I talked about this a bit before, but I don't think I actually did a demo. Does that sound about right?
I think we did.
Did we? Yeah.
I think so.
So do you remember what the principle was?
Yeah, you submerge it in molten solder and then you pull it out.
So let me see if I can get a camera angle set up here so it looks about decent. I think that looks roughly right. I don't know if I can get this closer maybe. Yeah, the idea is that solder dissolves gold. So we're going to try to form an amalgam with the gold melting basically, and as it's submerged in liquid solder. So a couple things here. Here is some solder that we're going to heat up. And we also need to keep the melting point of the solder as low as possible. Unfortunately, it's a little bit far away. Let me see if maybe I can put this over here. Something like that. Give me just a second. As long as we don't melt this too badly, which we might, but you know, for science. Okay, I think that's probably a better camera angle. Okay, so the first thing I do, and this may get a bit noisy, so can you still hear me well, by the way?
Yep.
Yeah.
We can. Okay, because I'm going to turn on the heat gun, and that may get a bit noisy. So just to kind of preload this a bit, what I'm going to do is I'm going to first melt the solder to about near its melting point. So to keep it as low as temperature as possible while still molten, I'm going to add flux to improve the contact with the die. And then we're going to let it sit there for maybe a minute or so to dissolve the wires. And then we'll go back under the microscope to inspect it. Does that sound good?
Mm-hmm.
Okay. Can you still hear me, or is the audio bad now?
I can hear you.
Okay. So first thing I'm going to do then is to melt the solder to the melting point really quickly. It'll take a long time to get up to temperature with the heat gun as is, but if we just let it liquefy, it will immediately be at just the melting point. So, okay, so our solder is now at just above melting point. I'm going to adjust this camera a bit more there. And I'm going to add a little bit of flux just to clean up the solder a bit. And take a little tool. I'm going to heat it up underneath the heat gun. You can't see this right now, but I'm preheating it. Otherwise, when it went in contact with the solder, it would solidify it because we're very close to its melting point. And I'm just going to clean the surface a bit here. It's very important to have a nice clean surface for putting the die in. Okay. Now what I'm going to do is I'm going to go grab some tweezers. Give me just a second.
This looks so much like mercury. It's not even funny.
Yeah, and it is worth mentioning, mercury is the more traditional method to do this. And this was me as kind of a compromise between mercury to deal with hazardous substances.
I was going to say for safety concerns, it's probably
yeah,
not the best.
I mean, I'm still using lead here, so it's not exactly the most safe. But I know a lot of people use basically hot mercury, which has some significant health concerns. So at least a little bit of a compromise here, although not ideal. All right. So what I'm doing now is I'm going to take one of these chips, if you can see this hopefully a little bit, and I'm going to put some flux on it to kind of just get it wet and prepare it. A little harder to do this on camera. Sometimes I will do this on a, kind of a Kim wipe or something, which allows it to distribute the flux a little more evenly. And one of the nice things about these carbon fiber tweezers is they're actually quite heat resistant. So as long as you don't keep it in here too long, it actually can withstand this sort of heating quite well. And I'm just placing this gently on the surface and just gonna bob that in a bit. Now, I don't know if you just saw that. It may be too far away to see, but most of the gold has already dissolved. It actually was very quickly, just kind of got sucked in there. And even still though, I'm just gonna poke this a bit and let that sit in there for at least a little bit. It's also worth mentioning, one of the reasons why I want to keep the temperature as low as possible is the flux can also burn rather easily. So by keeping it as low as possible, it's a lot easier to clean the dye afterwards. I am now filling a beaker with some acetone. You can kind of see this a little bit there. And I think we've probably let this sit long enough, at least for demo purposes. So what I'm going to do then is I'm just going to go in here, pick this up, maybe let it cool off a little bit, and then maybe just put it into this beaker now. So let's turn off the heat gun. And maybe I'll do is I'm going to switch back over to my main camera. All right, and now we have the dye, which is in here, and hopefully you can see that a little bit, a little hard to see maybe, but it's at the bottom there. And at least doing a quick visual inspection, which is going to be hard for you to see, it looks like all the bond wires are gone. So now let's take a look over at the microscope over there and see if we can see that in a little more detail. So bear with me as we walk over there. Any questions so far?
A couple of questions. So one,
Yeah.
does the solder ever eat into anything else on the chip that you don't want it to?
Generally speaking, the bond pads down there are aluminum or other kind of metals like that aren't as readily affected by solder. So at least in my experience, other than where the gold had actually chemically bonded with the metals below, you don't see a lot of damage on the bond pads.
Okay,
It tends to be fairly gentle.
Okay, very good. Second question, actually, does the solder ever stick to parts of the chip?
I was going to actually ask that next, if it ever sticks to the chip.
Short answer, no, but I had also experimented with some other alloys like Gallenstein, which has a gallium in it. And in those instances, the gallium actually did wet the glass, which is one of the reasons why I don't use those anymore. But at least with lead solder, it doesn't seem to be an issue. Okay, so what I'm going to do now is I'm going to get our microscope camera back up, plugging that in now, and getting my feet up. And let me share this over here now. So I'm going to do share screen and bring up tube light again. Okay, can you see my microscope camera feed?
Yep.
So there's our old dye, which I'm hopefully not going to blow away as I try to dry this out a bit. I'm just squirting some canned air there. And now I'm going to reach in. I should also point out I haven't very thoroughly cleaned this other dye, so it may be a bit dirty. But now I'm going to put below it the one we just did in the solder bath. Okay, so hopefully you can see that now. And you can see that all of the bond wires have been removed. It's a little bit dirty. If I was to clean it a little more with acetone, maybe even ultrasonic clean, or nitric acid or something like that, if I needed something a bit stronger. I also have some other kind of Gugon type chemicals, which I think also work pretty well.
Would you just drip the nitric acid on it, like just in really, really, really small amounts?
The way that I do it is I have a little what I call my cleaning nitric acid vial. I basically put the chip in this one that's like for very clean decaps only, and just a little bit, and I heat it up briefly, maybe a minute hot, and that's typically does a pretty good job.
Is it azeotropic nitric acid or fuming nitric acid?
I use fuming. I don't know if heating is strictly necessary since these are pretty reactive compounds, but that's just what I've been doing because I happen to have that set up. Room temperature might work fine as well. But honestly, something like Gugon might also be sufficient. I mean, we can also try that real quick if you want. So, tell you what, let's do some Gugon type stuff, and let's see if that works. So I'm gonna take this dye, and let me go back to my main camera for just a moment. Let's do stop share. So now I've put it back in the speaker, and give me just a second. I have this stuff, which I think is what I used before, which is, basically kind of a mixed solvent. And when I use this in the past, I really should be using gloves for this. Let me actually get some. I spilled some stuff of this on my hands before, and they felt like warm or something like that. So it makes
it's not mercury. Don't worry about it.
That's always a good sign.
I don't know if there's like DMSO in here or something, but let's just say that I got the impression I should wear gloves with this stuff. Yeah. But yeah, for example, I was using this to remove nail polish recently. I guess actually reflecting what it was. And that was quite effective, which was something that I had been using nitric acid for traditionally. So when it was stubborn, because sometimes it's really hard to get off if it dries. But anyways. Okay, so I've just swirled this around a bit, nothing fancy. And let's take this out now and see if it's a bit cleaner.
Was it dirty because of the solder, or was it dirty before you started?
It was actually the flux that made it dirty.
Okay.
If you remember, I had them up earlier, just like this one, right? That we have. Well, I'll put the microscope back up. Let me do that. Here's the other one, right? You see this one? They all roughly look like this. They're fairly clean. There was a little bit of epoxy residue on some of these, but nowhere near what we were seeing on this new chip. All right, I'm going to take the other one that we just did with the solder out of the beaker. I am putting it on a Kim wipe, little kind of paper towel-like thing, and I'm going to briefly wash it with rubbing alcohol, and then actually I won't wash it. Let's just put it as is and see what it looks like. It's a little bit dirty still, so I'm not sure how good of a job that did to it. Let's give it some alcohol and see if that. So you can see right there, it looks like it's maybe still a little bit dirty.
Looks like it's cleaning up though.
It's cleaning up, yeah. Let's actually. The whole thing is, I'm trying to avoid scrubbing it because I feel like scrubbing it would be cheating. So let me.
Yeah, no more foam swabs for you.
Yeah, I mean that will work though. I just want to be clear. I'm just seeing if just enough. That looks like it actually did not help that much. Now that I look at it, so it looks about the same dirtiness there. Maybe ineffective in this case, but at least in my experience, acetone works pretty well. If we were to, for example, put acetone in a little small beaker and put it into the ultrasonic cleaner, in my experience, that would also clean this up very quickly. The reason why I tend to use nitric acid over the acetone is simply that the ultrasonic cleaner can sometimes cause other damage, whereas the nitric acid tends to be a little bit more controlled in my experience. Make sense?
Yeah. Yeah, I noticed if I put enough acetone in the beaker and let the ultrasonic go on kind of not too high of a blast, it doesn't shake around too much. It shakes just enough where you just get the dirt out. I also don't leave it too long in the ultrasound. I'll probably leave it from maybe 20 seconds at a time just to make sure.
Gotcha. There is a YouTube comment I'm taking just a moment to respond to. Mike Brown is asking if we want random chip sent. Ryan, do you want random chip sent to you? Or
Sure.
yeah, so I'll say, can you contact us offline via Twitter or Reddit? Does that sound about right?
Yep.
Okay. All right. What do we have next on our list? I think we had at least one more way that we wanted to show. Okay, another one that I've done in the past was shearing. Do either of you by chance know what I mean when I say shearing for removing?
No, I've actually never heard of that
bond
before.
wires?
Is that like shaving it off?
Yeah. What I did before was basically I took a very sharp razor. I shouldn't say very sharp. I mean, it wasn't anything special. Hopefully I won't cut myself on this, but you know, ideally a new one if I can get this open without cutting myself.
Wait, you actually like take a razor to these chips?
Yeah, but there's a little bit of technique to it. Actually, you know, there is a guy, what's his name in Japan? Oh geez, I'm blanking on his name right now. I should know his name. He's doing the M1 open source work. Do you know what I'm talking about? Anyways, there's a guy in Japan that is known for actually delayering chips even with a razor and gets at least halfway decent results. Yeah, it's a bit crude. Yeah, you should definitely look it up if you haven't seen it.
Yeah, I have to see this.
Really, I should be using a very fresh new razor for this, but you know, YOLO.
You don't shave your face with that thing, do you?
You know, gotta save some money. It's tough times right now. All right. What I'm gonna do is I should have my little stockpile of dyes. I'm gonna get another one. I'll be right back. Now, if we were just to try to cut it with a razor blade as is, it actually will snap off and kind of destroy some of the bond pads, kind of like you alluded to before. One of the things that really attracted to me for this, the reason why I was curious in the first place, is I heard this technique was sometimes used. I'm going to switch back over to microscope view. If you wanted to rebond chips commercially in kind of large volumes, I heard this was roughly speaking the technique that some people were using, and that's kind of why I was looking into it. And so the idea is we actually want to mechanically support the die if we want to cleanly remove the bond wires. And the way that I came up with that was if you apply some sort of masking compound. I use nail polish as kind of my go-to for a lot of this type of stuff. And I'm just going to try to hopefully dab this down. Unfortunately, I just took the dye with it. Let's see if I can get that. Yeah, we're getting a little bit of a sticky mess here. And what I found was if you do this, it provides a little bit more mechanical support to the bond wires, and they tend not to rip out as easily. So I'm just putting a little bit of air on that to help smooth it out and dry it. And we're going to let that sit for just a moment. And ideally, if we were doing this very professionally, what I would also do is on the sides here, if I can indicate, I would also maybe put some sort of shim on each side and maybe affix the die down a little more securely with, say, maybe wax or something like that. So it's a little mechanically stable. But just for a quick demo, I'm not going to go through all that, but just FYI, if you were trying to do this and get a nice clean bond wire removal. And just to emphasize, the main advantage of this technique was I found it was a good way to lop off just the tops of the bond wires, leaving kind of gold studs below that allowed you to very easily rebond a chip. And at least with methods I tried, this was something that you could practice on a bit and get a very reliable process for doing that with a little bit more setup.
And you need to have the nail polish be just proud of the surface, right? Like you don't want too much of it, otherwise it's gonna hold on to the wires.
Sorry, say that again. I just got distracted a bit.
You don't want the nail polish to be too proud of the surface of the chip, right? Otherwise, it's gonna grab onto, because you're not cutting through the nail polish. You're cutting the stuff above it, right?
Yeah, I mean, essentially, we're gonna skim off a layer of it. So we want to leave like a very thin layer, ideally.
Does this also protect the chip itself? Like, does it protect you from scratching the chip with the razor?
It does. Although if you're on a relatively modern chip, it shouldn't be too big of a deal. If it's an older chip where the passivation is a little more uneven, then it causes more of an issue. Mike Brown also just pointed out that using DCM also works well to remove a lot of residues.
Oh,
That,
dichloromethane?
yeah, it's definitely a much stronger solvent. I think DCM also eats aluminum, if memory serves correctly. So I've avoided it at least for some applications, but I'm sure short exposure.
I've only used it for extraction experiments. I didn't know DCM could be used for this.
Oh yeah, it's a very strong solvent. Like once you get into like the DMSO and all those, it's kind of like the good stuff. DCM is good stuff.
Yeah, don't good stuff, but don't breathe it in.
Yeah, maybe don't drink it. Whatever. And then he also got the name correct. So Markin is the guy that I was thinking of that does the razor blade delayering. Thank you, Mike, for that. Okay, with that in mind, then I'm going to maybe turn up the brightness a little bit now because it seems like we're a little bit underexposed now. Hopefully that's a little bit better. And let me see if I can do this. So this is also not something I do a lot. I kind of did this as a demo a while back, a technology demo, and didn't do it a lot. But let's give this a try. Oh, it's not. I was hoping that was also going to kind of fix this down to provide some mechanical support.
Looks like you're about to cut a cake.
Yeah, it's not quite dried yet. Let me think. Maybe I could turn the rework station and dry it out real quick. This is not the recommended way to do this, as it'll also heat it up a bit. And it could cause some bubbles. Tell you what, I'll be right back. I'm going to cook this on my heat gun. Just a moment, please.
Try using DCM next time. I'm not confused though.
So I just did a quick blast of heat on it. Let's see if that helped. It definitely dried it a lot more. We're not dry yet, so I've got a little bit longer. And if this is not stuck, maybe I'll just see what I can do as is. All right, how are we doing now? Okay, well, you know what? I'm just going to hold it best I can, and we'll see if that's good enough.
It's a little off center on the camera.
And is that better?
Yep.
Yeah.
Okay, so what I'll do then is maybe I can try to hold it down. And part of the issue too is you should try to get this as flat as possible. So the way that I'm holding this now is a little bit difficult to do that. But I'm going to try to do then is I'm just going to try to yeah, this is not the ideal setup to do this. Maybe I should have fixtured this down because I don't think I'm going to get the right angle here as we're doing this now. Let me try. So I can also push this against the edge over here. Maybe that'd be better. Okay. So okay, perfect. Actually, that went okay. Did you see that?
Yep. That was a nice chunk to come off.
Okay, but do you also see if there's like shiny? So maybe I can let me try to get in there because I think that's hard for you to see right now.
I'm not gonna lie, that was kind of a nail biter. I kept thinking you're gonna shave the chip off.
So mind you, I didn't have the ideal setup for this, and the main thing I want to show is the potential of this technique because I didn't quite have the right setup for this. Let me see if I can get the exposure down so it's a little more clear what happened there. Nice. Do you see those kind of shiny circles there?
Yep.
So in the middle, that's where we have the right level of spacing. And you can see those are actually shiny gold contacts there. And those would be great for rebonding. I think on the sides there, I cut a little bit too deep. And you see we actually damaged the pads there. But with proper kind of fixturing on this technique's really good for if you want rebonding. But you do need to have it a lot more steadily fixtured than I did right now. Kind of like if you try to drill something without it being clamped down, you just don't get the right effect. But anyways, that at least gives you an idea of what I was trying to go for here. If that gives you an idea.
Speaking of physically like pulling out the wires or cutting the wires, what about a milling kind of setup? So I know you have those sanding stations where you take the chips and sand them down and pull layer by layer off. Have you tried that, like coming in and just routing the wires off?
Yeah, that's a good point. You probably could sand a chip down while it was still packaged and then decap it afterwards. And I think that would also give you a similar effect. I haven't tried that, but I imagine it would also work pretty well. Um,
Or
that's
even
a
like
good point.
like a milling station, right? If you just come in and have the bit go and comes lower and lower and just like cleanly chop up the wires.
You need a really precise milling station for that, though. I feel like the needle tip would need to be super fine.
Well, as long as the pressure was correct, I think it would be fine. I did some back thinning with my milling machine, which is not particularly high precision. Let me see if I bring it up over here. It's a, oops. Did I lose the feed? I don't see you guys now. Oh, there it goes back.
Yeah, you stopped
So yeah, so if
presenting.
was that?
No, you stopped presenting, but that's
Yeah,
okay.
that's fine. I just want to get that. Yeah. So over here, I have a Shoreline 2000 CNC, which is a pretty entry level, CNC milling machine. I was able to back thin ICs with this, with a little bit of tuning by using some, oxide bits, something like this. And I was doing extremely precise cuts essentially. So I think with a little bit of tuning, you can make it happen. It's just a question of how much you want to practice to make that work.
I'm actually shocked that you were able to use it with something that thick.
Thick? What do you mean?
I mean that piece they're using was kind of fairly large for dies that are so tiny. I figure it would take up the whole chip.
But it had to do more with how much pressure I was applying and using that to remove very thin layers very precisely. It was almost more like polishing than like using a milling bit or something.
Because it almost has to like barely touch it, right? It has to like get so close to the bond pad where it's not exactly touching it, but just touching the wire enough where it spins it out.
Yeah. But with a little bit of practice and using a what they call micrometer to kind of measure how much material I was removing, I was able to at least kind of figure out what that profile looked like to get very small cuts with a little bit of practice. Okay, let's see.
Even with your razor blade technique, if you put
Yes.
a couple of guide shims on the side, and front and back, you should just be able to like put decent amount of pressure and slice them off, right? Because the guide shims are going to protect the chip.
Yes, and to give you an idea, if I was doing this really seriously, I might use something I might use is if you've seen like spark gap gauges, these things are pretty cheap. These sort of shims. So I would probably use something like these, which I don't think this costs very much. Yeah, and I think you could match this to the die thickness and set something up pretty easily. Okay. I think the last major topic we had for today was possibly using acid etching to remove bond wires. It sounds like, Ryan, that's something that maybe you...
Yeah, I can talk about.
Yeah, why don't you talk about that a little bit, and maybe while you talk about it, I'll try to see if I can set a demo over here. Does that sound good?
Yeah, cool. Yeah, I mean, I totally would do it, but like for me, the process of having to work with acids, it's like I have to get this whole hazmat suit,
and over here, it's more like safety third. So
I know. For me, it's like I'll do anything I can to not die. For Don's just like, yeah, maybe I'll put on like
the show must go on.
The show must go on. Yeah, I'll explain the first method I use, which is creating a kind of like a copper to chloride solution. And basically, what you're doing is you're using a 1-to-1 ratio of hydrochloric acid and hydrogen peroxide as the oxidizer. So I use very little. I'm talking like 3 milliliters to 3 milliliters of hydrogen peroxide to hydrochloric acid. Once copper is introduced into that mixture, which is hypochlorous acid, it automatically becomes a copper to chloride, which you can tell by the greenish color. And you'll know that it's working because if the copper bond wires will start to turn the solution green, because it's a very, very small amount of copper, you're not going to see the whole solution turn like greenish green. but you will see like a cloud of green start to surround the chip. You're not going to leave it in for more than 30 seconds, I would say. After that, you wash the chip out with water, and the bond wire should be completely off. The other method that I've experimented with in the past, that I will take one of these foam swabs, and I'll pour some ferric acid into it, which is iron 3 chloride. It's used for PCB etching to etch copper out. So what I'll do is I'll put around 5 milliliters in a beaker, and I'll take it fast, and I'll start brushing the sides of the chip itself. Because ferric acid reacts super violently with copper very quickly, this has to be done within a matter of seconds. So by the time your foam swab touches the die, within about, I would say, 5 seconds, that die has to be put back in water so it doesn't corrode the actual chip. It's not a method I recommend because of how quickly ferric acid reacts with copper, that it could damage the chip itself, like the aluminum layers of the chip. But that's why I like to go down the copper 2 chloride route, which is the hydrochloric acid and the hydrogen peroxide, which John is about to demonstrate.
And that's good for copper bond wires, right?
Yeah, because ferric acid is specifically used for, I mean, what they use in this industry is for PCB etching, which is etching out copper.
Do you use any other types of materials for other bond wires?
If it's any other type of bond wires, I'm still going to use hydrochloric acid, because even if it's aluminum bond wires, the hydrochloric acid will eat that very quickly. But like I said, its timing is very critical, because it can also eat the chip as well and start to delayer it. But it won't delayer it as fast as something, let's say, like hydrofluoric acid will. Like, you really have to let it sit in there. And also keep in mind, this is at room temperature. Because hydrochloric acid is very volatile, there's no need to heat whatsoever. So that's the other benefit of it, that you don't even need to heat this solution up.
Okay, if you are ready, then I will do a little demo here. Good?
Good.
And this guy says safety third. Look at him, all safety.
Well, you know. All right, so I'm going to share. We're going to get the microscope view back over here. And maybe I should have shown first. I have a little pipette here, a little bottle with hydrochloric acid, which hopefully I won't spill while recording here. And the idea is we're just going to put some acid down here. And I think hydrochloric acid should just be enough in this case. And hopefully that'll knock off these bond pads rather quickly. So just flipped it around a bit, which is unfortunate. So I will see if I can flip that over. And hopefully we can watch this a little more closely. Okay, there we go. So flip back over. And maybe give that a second and see if those bond wires start melting off. I think I can see some bubbling there. That bubbling should be the actual bond pads degrading. You know, for depending what you're doing, this could be a big deal. But if we just want to get rid of these wires, it's not a big deal. So I'm just going to slosh this around a bit and see if these wires start to fall off. Maybe not yet. Give that a little bit more time, but you can see bubbles rising there, and this chip is, you know, having its soul eaten now. You know, it's going down a dark path. How long were you doing it for, Ryan, before?
It's about third, because I mean, you don't even necessarily need the hydrogen peroxide for it to create the copper 2 chloride. Hydrochloric acid plus copper itself can create CuCl2. It's just hydrogen peroxide is a stronger oxidizer for it to react faster. But if I were not to use the hydrogen peroxide, it could take anywhere between 3 to 4 minutes.
I see. Okay, I could add some hydrogen peroxide and just see what happens.
I would probably recommend using some hydrogen peroxide. And you actually start to notice it turn greenish. Actually, maybe not from this light, but.
So if you can hear me, so I've got some 35% hydrogen peroxide here now.
I usually dilute, if I have 30%, I usually dilute it to around 12%. So I'll add some water to dilute the hydrogen peroxide.
YOLO. All right, here's a drop. Let's see if that noticeably changes anything. At least that bit doesn't look too. Let me add one more drop. See it sit there for a second.
You need to agitate it to get the bubbles out of the way.
I'm wondering, I could try knocking it. It's probably gonna knock it out of focus though. Yeah, it could be honestly the bubbles at this point could be dominating. Now, normally though, we also wouldn't do this under a microscope. You know, we're just doing this for, you know, visual effect. I'm gonna zoom out and maybe I'll try agitating it a bit. Yeah, so let me try swirling that around a bit. I'll see maybe if those wires fall off. Oh, I think I saw them falling off. At least one of them did. So once again, I'm trying not to actually put any pressure on the bond wires. I'm just seeing if they just fall off on their own accord. Maybe I could try gently wiping them. Because remember, on the other ones, it was very strong, right? So if they just kind of naturally fall off now with just the slightest bit of wiping. So I'm just touching down on it. Okay, see what I just did there? So I didn't even wipe it. I just tapped it. And it looks like that was enough to knock them off. So maybe surface tension or something like that was kind of holding them in place. But
and normally what I would do in this situation, after I make the solution, you dip it in there. If you put it back in water to clean the acid off of the chip and do an ultrasonic bath for 10 seconds, the copper wires will just split off.
Oh, for sure. Yeah. Anyways, so I would say one of the things about this is a very accessible technique. I wouldn't recommend this though for older chips, which have more fragile oxides. They tend to have a lot of holes in it across the chip, and you end up getting a lot more damage than just around the pad frame. And this chip is also going to get a bit of damage from where we had the where the bond pads were. You know, the acid's going to start seeping in. So if you do want a nice result, you need to clean it fairly soon afterwards.
So, yeah, I was going to say, don't let the acid sit on the chip for too long.
I'm going to go clean this up. I'll be right back.
Ryan, aside, like, you know, we discussed this a little at the start, aside from the aesthetic reasons, and maybe if it gets in the way of, you know, actually looking at the layer, are there any other reasons why you really want to take out these wires? Like, can't you just fold them out and, you know?
You totally could, and I've done that before too. As you can see with that chip that I was using, I had like 3 wires left that I didn't even bother to take off because it wasn't hurting my images whatsoever. But what I did notice, if you are going to delayer your chip and the copper is still there could be a chance that the copper can burn into the chip itself, or create markings while you're delayering it. So let's say you're getting to the polysilicon or even the substrate layer. If there is copper wire like on the chip itself, it could have a chance to just kind of stay there and then just be burnt on it. And I've had that happen before with a couple chips.
Yeah, because this definitely does seem like a pretty big step. Like it could, you know, ruin your whole decap and ruin the chip if it goes bad.
Yeah, you have to be very careful. And I did that with one of my CH340s that I was doing. It completely broke my chip in half. It can be a very sad process when you're like, oh god damn it, like just for removing these wires I pretty much just ruined my chip.
I would also add for me that, you know, if you have the wires on there, sometimes it can, if I'm wax mounting it or something, they also can get in the way and make it hard to get a nice clean level image.
See, this is why I like hydrochloric acid. Look how clean that came off. Like that is such a nice removal of wire, and like the chip shows no dirt on it whatsoever.
Maybe we can finish this up with one last thing. Maybe I can try to actually get these under a proper microscope so we can compare them.
Yeah, while you're doing that, I'll talk about another thing that I do. Another method too, because I do use sulfuric acid to do the decapping. If you let the chip, so generally when I'm decapping chips in sulfuric acid, after the whole solution turns black, it's kind of hard to tell whether the epoxy is completely gone and the dye itself is in the solution. So I check like every 15 minutes, I'll pour the fuming hot sulfuric acid into another beaker. I'll take a look around. I'll see if the dye is still it. If the dye came out, or the dye is attached to me wires itself, or still attached to the bond pad. So generally what I'll do in that situation, sometimes I'm feeling really risky, I'll put the sulfuric acid back in for about 2 minutes. And then I'll quickly take it back out. And by that time, the paddle and the wires itself normally just come out. Because I've had situations where I will decap a chip and the paddle underneath the die is still stuck to it. And it literally looks like it's like glued on, but that's because I just didn't let it sit in the acid long enough for it to separate. So yeah, sometimes leaving in sulfuric acid for about 2 minutes will take away all the copper wires. But like John said, it's going to leave you some pretty ugly burns. I mean, I don't mind the bond pads looking a little burnt, in my opinion. To me, it's not a big deal. But if you want them to look super clean, then I would go to hydrochloric acid.
Mm-hmm.
But sulfuric acid will eventually take off that color.
I was thinking, I guess the bond wires are attached. They're not soldered on, right? Like they're lasered on or mechanically like embedded, right?
I don't know how. That's probably a question for John. I'm not sure how during the manufacturing process they put these wires on. I always thought they were like micro precision soldered on, but
Can you hear me?
Yeah, we can, but there's no video.
That's expected right now. So use something called a wire bonder. I actually have one right next to me right now, but unfortunately, I'd prefer not to turn the video on right now to show you. But basically, they use ultrasonics and heat, which creates basically a coldish weld, I guess, of sorts, and bonds the metals together.
Okay.
That's the most common industrial technique. Could be a subject for another video, but I think probably don't dwell too much on that for right now.
Yeah, because I was getting at like if they were actually soldered or some other way attached, if you could just heat them enough, and would they pop off?
Oh, like using like a desoldering gun almost?
Something like that, right? Like whether you could heat it up enough that the wires would get affected, but not the chip.
I'm curious actually what would happen if I took a desoldering gun to it. I mean, I have one right behind me.
Okay.
Yeah, but I guess it seems like it's a weld, right? It's not a solder.
Yeah, it's close. It's closer to a weld, I would say, than soldering. At least, I don't know, maybe in between the two. I'm sure someone can correct me.
But it's probably so thin that a desoldering gun would heat it up enough where it would probably release the wire, right?
No, I don't. I think
so.
I think it would require much higher heat. Okay, I'm going to share this. And okay, can you see that now?
Yep.
This is the first one we did. This was done with the Q-tip. And there may be some questions here. Ryan C. you got a question there.
Oh, no, because Mike said, isn't that piranha solution? And I said, that's sulfuric acid and hydrochloric acid.
Yeah, ours was closer to aqua regia, but even then, that's nitric acid and hydrochloric. Anyways, here was the thing with the Q-tip. So we see a few things here. One is we have those little gold nubs, and that's where the bond wire was fatigued from moving it around a bit for the most part. We see one that's a little bit longer, it didn't break at the very base. And then we also see a few pads that actually got damaged there. So that's where it looks like it actually ripped into the chip a little bit and took out some with it. It didn't go so far to actually rip all the way to the silicon, but I have seen that on some chips. So this is what you'll kind of get if you use the Q-tip, at least roughly speaking. If you kept sort of scrubbing, if you wanted to, you could actually rip off the remainder of that gold and get bare pads like the others. These are not suitable for rebonding though. As you see, most of the metal is gone at this point. Any questions there?
Nope, I think that's good.
Okay, here is the second one, which was the solder. And unfortunately, we didn't clean this. Maybe I should have done that more.
Yeah, that one got really dirty.
Here. That's okay, though. You get the basic idea over here. Okay, can you see that there?
Yeah, that's good. You got it.
And this is one of the reasons why this was my gold standard for a while, is this seems to be relatively gentle to the die. You get these nice little nubs, not really risk of scratching it. I haven't had issues with thermal stress or anything like that. If I could raise the exposure here. I don't know what happened there. Oh, well. Anyways, yeah, so I felt that this gave pretty good clean results. It doesn't damage the chips a lot. And it was pretty quick, like you saw. So this is the reason why I use this technique for a long time. And I may continue to use it, on a case-by-case basis. But in general, you can see this was a little more gentle on the silicon than the applicator method that we'd used before this. And then finally, let's take a look at the chemical method. And I suspect we'll see some more damage here, but let's take a look. Yeah, okay. Let's see if we could find a better example where the damage shows a little more clearly. Give me just a second. Okay, here's.
You won't find any damage because this is the best method.
But no, I've got some damage up now, so I'm gonna focus on this because we need to show why you might not want to use this method.
Can't see it if I'm not looking.
Okay. Unfortunately, I don't have a pointer, but we can see that large portions of the bond pads are gone, right? All the wires are gone. But you also will notice that metal power trace on the outside is also starting to be eaten into, right?
Yep.
Yeah.
Now
and you do have a mouse pointer actually if you want to move it around. It's pretty clear. Yeah.
Oh,
right
okay.
there.
That's good. Yeah, so you can see that there. And, had we done a shorter exposure, which we could have, because, we didn't realize how weak the bond wires were on there at that point. I think we could have done it a lot shorter, and this damage here would have been minimized because this area is directly exposed and attacked a lot faster. It looks like there was maybe a little bit of welding down here, which was, I think there's that little spot that we're seeing there. And that was probably just barely keeping those bond wires on, even though we had destroyed most of the support structure at that point. But yeah, this damage, especially on older chips where they have little holes in the oxide layer, you would also see that damage just throughout the die like here. But because this is a more modern chip, which tends to have a lot higher quality passivation layer, you tend not to get that sort of severe damage that I've seen on older chips. And that's the main reason why I've shied away from this method, but it seems to work acceptable on at least newer chips, without too much damage.
I will say, if I can share the screen for 1 second, why
Sure,
I
yeah.
actually
Stop there.
agree with you on the damage portion. So if we can look at this chip that I decapped a couple of weeks ago, I actually didn't use the hydrochloric acid method to take away these bond wires. I used gentle swabbing with isopropanol, and as you can see, what I like about it is that because this is a 16 pin chip, I was able to differentiate between what were the test pads and what were actually attached to the bond wire, the chip itself. Because if you count total, it's not 16 pads you see on here. It's going to be 16 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's 13 extra pins. And now if I were to do this with hydrochloric acid and we were to damage where the pads actually were, and they would all look like this. And the problem is when this comes to reverse engineering and you want to kind of figure out where the pins are, it's going to be kind of difficult to tell which one is a test pin, which one is a test pad, and which one is not a test pad. So in that, John, I do agree with you that sometimes preserving the metal on top is very important, because when you are in a situation where you do have extra pads on the chip that actually never had wires attached to them in the first place, it's important to differentiate between the two.
Gotcha. Makes sense. Interesting. Let's see. I think that is the vast majority. Maybe there were a few small, quick follow-up topics, and then we can open up for additional questions. We had a miscellaneous section here about methods that generally either were not recommended or had failed when I tried to use them. The first that's worth mentioning is I had tried to use tape and hot glue to pull up wires, but generally speaking, I couldn't get the wires to reliably stick to those sort of compounds. And so I haven't really gotten a lot of use of that method, but occasionally it has worked to quickly pull off all the wires from a chip. Any thoughts from either of you on that?
I haven't used that method, but one very careless method I would do with tweezers, instead of trying to individually pluck them out, I would take like the really sharp tip of it and try to scratch them out. So I'll go to like the bond pad and just literally rub it a little bit.
Yeah, I have done that. It's really easy to badly scratch the die doing that.
Very
so
easily.
kind of
like I've had cracks go all the way down the die because of it. It's not pretty.
Yeah, and on that same note, just to emphasize, we talked about, the type of tweezers you use. If you did that with metal tweezers in particular, oof, yeah, your die might get a little bit roughed up.
Yeah, for sure. I'm trying to think of like other situations where.
Well, another thing that I've tried, which I think in theory could work and have good results, is I also tried to use a cyanide etching.
Really?
Which I've heard in so in microelectronics, apparently cyanide is one of the highest quality gold etchants you can use. I believe it's also fairly selective for gold over other metals. The sodium ions, I can imagine in theory are an issue, but I'm not sure if in practice they're a real big issue. But
you have to use pure cyanide, or can you use like a safer one like ferrous cyanide?
No, sodium cyanide, I believe, is the recommended one. I think the etch rate is really slow, or I wasn't doing it right or something. I wasn't able to get decent results, at least with a quick test that I did. I don't know if I need to heat it more or exactly what, but yeah,
you can actually use potassium ferrocyanide for gold and silver etching.
Obviously, if you try something and you have some better results than me, I would love to hear more. But at least the quick experiments I did, I wasn't able to get something interesting.
I will actually order some potassium ferrocyanide, and I'll let you know how it goes.
Sure, yeah.
Looks like a lot of people have been talking about using potassium ferrocyanide for this.
Part of the issue is that most people who are dissolving gold are using it for metal refining, and they have different kind of goals and economics than me. So it was a little bit harder to find, relevant stuff. Because once you get into the more exotic, cheaper stuff, there's like some urea compounds you can use and stuff. But a lot of these have side effects etching other metals. So it looked like they weren't generally in the right direction for me.
Yeah, I'm trying to think, because potassium ferrocyanide comes in salt form, and you'd have to, wondering how much ratio you'd put in the water to get a good solution. And then for how long would you put it in there for too?
It is worth mentioning, though, I did try also a mixture of sodium iodide and iodine, but I recall that it ended up eating the other metals. So that turned out to not also be a good route to go down. Let's see. I think that's everything that I have. I don't know, Yusuf, if you have any more follow-up questions, or Ryan, you have anything else to add?
That's it for me.
Yeah, no, I think these were, quite a few good methods to try out. I actually would be more curious to go down the path of like the mandolin type thing, where you shave it on the rails, or like a lawnmower, or Phillips like shaver, right? It's like
an actual lawnmower, right?
Yeah.
Yeah, like I said, I think that there are some cool things you can do there. Unless I'm actively trying to rebond them, though, it is quick. Like you saw that I removed them really quick, but it's also competing with some of the other methods. And I'm just not sure if it adds, unless you really want to rebond the chip, I'm not sure if it's worth the effort.
Yeah. Yeah, and plus, I mean, this is not, high volume, right? It's quite a small amount of chips you work on.
Yeah, and that's the thing is I also got the impression that technique was really nice if you needed higher volume. Like for whatever reason, you need to repackage a bunch of chips. But since this is more on the kind of prototyping, low volume side,
yeah,
not as valuable. Cool. Well, if there's nothing else to add, I think this is probably a good point to end the stream. Unless there are any last minute questions from viewers. Going once, going twice. Well, with that then, I think let's thank everyone for watching. Thank you, Yusuf. Thank you, Ryan, for joining me. And I guess I'll see everyone next time.
Yep.
Thank you so
Thanks
much,
a lot, guys.
Bye-bye.